Hello, everybody. Hello, and thank you for coming in here today. I'm happy to be your first host here. I'm going to be warming my hands a little bit because I had a pretty cold journey here. My name is Mark, and today I would like to inspire you perhaps a little bit to just think a bit more about how you design your errors and what you do with them. Isn't it a perfect topic to start 2026, a new year of Go with error handling topic? But no, hopefully this is going to be a little bit different. So let's start with a problem. So what's the problem? Well, the thing is that eventually, after some time, the APIs grow and they end up with an error strategy. A very elaborate one that might look something like this. If you've seen this before, those are some errors that you can see an API returning to you. Those are real examples, including this one. And maybe you're happy if you see oops, maybe you're not. But we're here today to actually debunk the problem, because what are the symptoms of such errors? Well, the first is this what the F moment that your API consumers may actually live through when they see an error. It's not you, it's us. Well, very descriptive, but what does that mean? Or your frontends define conditional logic based on if, oops, then. Your tickets start popping up, but they are very much the same, and they just state it doesn't work, and I don't know why. And you might have meaningless logs, because all you see is 400 bad requests there, with no actual error description, and it's difficult to find the root cause and debug it. So bad errors make lives difficult for you, for front-end developers, for API consumers, for your clients, for anyone. So why does error handling actually falls apart? Well, we're actually pretty good at modeling success paths, but errors, well, we tend to think about them as an afterthought. And that may not be the best idea, right? Because what we usually do is that we design the success paths first. We sort of test the happy paths, catch some errors. Then we throw exceptions, sometimes as strings, sometimes we just rethrow them. We pick API, HTTP status codes on the fly as they come from our third-party integrations, and then we just return them to the transport layer. And we sometimes even use them in the domain layer. But what's not happening, but should be, is an explicit domain error design, shared language for failures, stable error semantics, and separation between the domain and the transport. So the error handling falls apart when we treat errors as incidental implementations, as incidental implementation details. But instead, we should think of them as part of our API design, which is what I'm going to at least try to propose to you today. So how to do it better? We'll start by modeling domains explicitly. The technical framing on the left is a string 400, bad request, invalid input, request failed, something like that. I would like you to switch the mindset a little bit and start thinking about errors in terms of business framing. In Go, we already treat errors as values. That's awesome. But the problem is that we don't really distinguish between expected business outcomes and unexpected failures. And this is where the business framing comes into mind. For example, right, if a user doesn't have enough funds on their account and they order a pizza, that order should fail. Is this an unexpected failure, or is it an intended business outcome that the order does not come through? It's a state of the application, right? You don't have enough funds. You should inform that user about that state and why the order doesn't come through. So we should think about this state, these expected business outcomes in advance, and model them properly, just like we model any other business aspect of our application. So if you remember anything, 8 errors are not technical failures. They are states. Okay, bad codeware. I, of course, would like to show you something tangible, something you can take over with you and implement it in your application as well. So a typical backend architecture, hexagon. I'm not going to stop for much longer here. This is just for introduction, so you can think in terms of the service architecture that I'm talking about. Here, an example structure within your repository. So what you have here are API errors, domain-specific error codes, and generic domain error model. Something like you can structure your repository something like that. Now, what is very useful is to model the domain error explicitly in the domain itself. So this is a generic domain model that you can use. You can see it has some private attributes in it, like a wrapped error, like a message that you want to eventually pass through code, pay attention to the code, and some additional data. And it fulfills the error interface or satisfies it. Now here, notice that we are in a specific domain now. We're in a portfolio domain. And the domain itself defines the code and defines relevant business outcomes that can happen within that domain. For example, portfolio not found, portfolio already exists, or position not found. This is defined within domain. Now we have constructors that use these specific error codes that we've defined in that domain, again, within domain itself. So for example, a constructor like new portfolio not found error. I'm gonna continue over. I'm gonna continue on in a bit, but let's go over the key concepts that we have when modeling the errors. We want to be explicit. We want to know what the error means and why it might have happened right when we read the code. We want them to be domain-oriented, centered around the business. We want all our domain errors to use the same language. We want them to be ubiquitous, and we want them to be unique across all domains so that we can distinguish them. But especially beginners in Go often ask, okay, but where do I expose domain errors? Where does it start? Should I just bubble them through the whole application? Yes, because errors are storytelling in Go, and you should start from the origin with every story that you just create. So try to ask a question, what state the error represents, and find the component within the backend application that can answer that question. So for example, here is a repository function that updates a portfolio. And here within that function, it's in, again, a domain repository. Here within the function, only this function knows that when I try to update the portfolio and I am not able to find the portfolio ID, it's portfolio not found error. If I break a foreign key constraint portfolio color ID, only then this is new color not found error. And only this function knows it. So this is the origin of this domain error. And that function should actually pass it to the top layers. Don't pay attention to this wrap function. I'm going to come back to that later. Right? So here you get basically all these specific error functions, specific error conditions that may occur within this specific repository function. Okay, so we somehow know how to treat them in the domain, but how do we actually get to the transport layer? Start with a wrapper. We probably want to handle all errors that happen inside of that handler. So let's define a generic handler. We have a signature package, which you might look up later, which I use here with a wrapper that we have. And we use that to define an error handler and use that wrapper here. This is simple, and all that the error handler does is it converts an error to an API error. Well, how does it do that? Well, the conversion function itself is actually rather complicated but simple at the same time. So what we want is to actually just convert all the domain errors that happen within that function and extract from that domain error the error interface itself, the status code that we need, and that's basically it. And then we want to translate that into the error. Notice this is error defined in the REST layer itself, in the transport layer. So here, how you can do that, the extraction from the domain layer, from the domain error, is a very simple errors S, which is standard library. Since your domain error model satisfies error interface, you can just unwrap it and find out if this satisfies this definition. And here, the important part is, since you've defined the domain error as a generic error type, and you used the code from the particular domain, you know from which domain it actually came from, which is super useful because now you get generic. Oh yeah, I do have that. Okay, cool. So now you get generic domain errors here. You get portfolio errors right here, which use dom-portfolio.code. And you can actually distinguish different HTTP codes on the transport layer that happened in these domain functions, satisfying proper hexagonal pattern, and still having the separation of concerns. Domain does not know anything about the transport layer, but the transport layer is able to use the domain codes as it should. And you can easily build on top of this, right? Here on the left, again, the definition that I showed you before of the domain error. And on the right, you can actually build on top of it. So what's quite useful is just to define a wrap function. The wrap function wraps the original error that happened, and you can log it or send it to your sentry, for example, if you want. You can attach additional message or overwrite the message that was there, and you can add additional data. Now, this is something that I want to highlight specifically. That's not used very often. And here is an example where it's super useful, especially to your API consumers. Because remember, anytime you return an error, there's a client on the other side that will receive that error. And you want the clients to know and visualize that error to the user, right? Because very oftentimes there is a front end. So, for example, if the front end attempts to update a user, and they provide this, which is a payload for that user, and these are all except for the passcode. Oh, well, yeah. These are all some updatable attributes, right? So in one call, for example, they can send either email, phone, text ID, or all of them. And you want to return to the front end what actually went wrong, right? So here, you might say, hey, this user already exists, and the email is the problem. Or, hey, this user already exists, but the phone is the problem. Or, hey, this user already exists, but the tax ID is the problem. And this is super useful to the front end, right? And again, only this update function knows what the problem was because of the constraint that it broke. And only this function can return this data. Cool. So the takeaway from here is that you should treat errors as states of your API. You should design them carefully, and you should model them explicitly, right? Your future self will thank you, as well as everybody else who will consume that API. Great. Space for questions.